When we look at different depths of our oceans, we're going to see that the temperature, salinity, and density changes pretty drastically from the surface of our oceans near the top all the way down to the bottoms of our ocean, the sea floor. First, we're going to cover how temperature changes with depth inside of our oceans. And we're going to see that it changes differently if we're at a low latitude, like around the equator, or if we're at a high latitude around our poles. If we're at a low latitude where we get lots of sunlight, we're going to see that a thermocline develops. And a thermocline is just where we see a really rapid change of temperature as we start decreasing our depth or getting lower inside of our oceans. And the thermocline happens in the upper 1,000 meters of our oceans. And here, it kind of creates a vertical barrier in our ocean. We're going to see that the uppermost area where the thermocline is, the temperature is going to change very rapidly. And then beneath it, the temperature is going to stay basically the same at a really cool temperature of about 2 degrees Celsius. It never gets down to exactly freezing. But at our high latitudes, this thermocline, the change in temperature, does not exist. And that's because at our high latitudes, at our polar regions, we get very little sunlight. The sunlight does not warm up the ocean surface like it does in our low latitude regions, and the surface of our oceans around Antarctica is covered in ice. So in our high latitudes, we don't have a thermocline. The seawater just stays very cold from the very surface down to the deepest depths. The density of our water also varies with depth. And density is just how heavy something is for its size. So with density, it's very similar to that specific gravity, like we talked about with minerals. If you hold two things, one in each hand, that are about the same size, and one feels heavier than the other one. So density is just how closely packed are the molecules inside of this material. And we see that the density is going to be affected by two things: the salinity, how salty is the water, and the temperature, how hot or how cold it is. So if we increase the salinity, if we add more salt to our water, we're adding in salt molecules to more water molecules. It's going to increase the density. But on the other hand, we'll see an inverse relationship between temperature and density. Because as we start increasing our temperature, warming up our water, the water will expand. The molecules won't be so close together because it's expanded, and it will lower the density. And on the opposite end, if we start decreasing our temperature, that water will get colder, it will compact, and increase the density. But just like we saw with temperature and a thermocline developing around our equator, with density, a pycnocline develops around our equator. And this is just in the uppermost regions where we have a really quick change of density with depth. But again, like we saw with our temperature, the pycnocline it's not present in our high latitudes due to the fact that that water is already very dense due to all of the sea ice around our poles. And here you're looking at an image of a lady just floating in the Dead Sea. This is the densest water on our planet because it's such a high salinity. There's so many molecules packed together that you cannot swim inside of the Dead Sea. We can see that she is floating. She would not be able to dive down because the water is so dense. It will always keep her body on top of the water. So if you don't know how to swim, the Dead Sea is the place to go. All of this leads to our oceans having different layers. Kind of like a 3-layered cake, we see that our oceans have 3 layers on most of our planet. Because we don't have the thermocline or the pycnocline, those rapid changes in temperature and density in our high latitudes around our poles, we don't have this layering there. But everywhere else on our planet, we see that our oceans are layered in 3 different layers based on their density. The uppermost layer is called our surface mixed zone, shown here in pink. This is where we're getting all of our rainfall and runoff from our continents. So it's a really low salinity, high temperature, low density area. The majority of our water, though, is found within the deep zone, and this is found along our ocean floor. It's called the deep zone because it's the deepest area of our oceans. It's not getting sunlight, so it's really cold. It's also at a really deep depth, so the water's under a lot of pressure, meaning that it's going to be a really high density and a high salinity as well. And then in between these two, we have this blue area that's called the transition zone. And as the name suggests, it's just where we transition from a warm, low salinity surface to a cold, high density, high salinity deep zone.